All right, let's talk about tropical cyclones. I mean, have you ever really thought about how a simple cluster of rain clouds can suddenly morph into this monstrous spinning storm that's powerful enough to flatten entire cities? Well, today we're going to dive right into the heart of these storms. We're going to uncover the secrets of how they're born and where they get all that terrifying power. Okay, first things first. Take a look at this image. I know, it almost looks like some kind of abstract art, right? But it's not. This is a real-time radar image of a super typhoon. And that calm-looking circle right in the middle, that's the eye. It's this incredibly deceptive calm, surrounded by a wall of wind and rain, so powerful it can literally tear buildings apart. And all those bright reds and oranges, that's where you've got the most intense rainfall, the kind that leads to just catastrophic flooding. It is absolutely stunning, but also pretty chilling. A real display of nature's raw power. So that's the big question, isn't it? How on earth does a simple cluster of thunderstorms grow into something that powerful? I mean, it seems almost impossible, right? That a few storm clouds could organize themselves into this massive, terrifying force. So let's do it. Let's break down the recipe for a typhoon. Okay, so to really get how these storms work, we've got to start with the basics, the fundamental ingredients. Think of it like we're baking, but instead of a cake, we're making a typhoon. And ingredient number one is something called an air mass. The easiest way to think about it is like a giant bubble of air. And this bubble basically takes on the personality of whatever surface it's hanging out over. So when you have an air mass just sitting over a huge, warm, tropical ocean, well, it's going to soak up all that heat and moisture just like a sponge. And that becomes the perfect fuel for a storm. This is, without a doubt, the crucial first step. So now you've got this fuel, this warm, moist air, and this is how it turns into a self-powering engine. It's this really elegant 5-step cycle. Okay, step 1, the sun just beats down and heats up the ocean. Simple enough. 2, that hot water evaporates, creating all this super moist air. 3, this moist air, which is lighter, starts to rise. As it goes up, it cools down and releases a ton of heat. And this is the key moment. Step 4, that sudden release of heat causes the air pressure down at the surface to just plummet. It creates a vacuum, basically. So step 5, air from all around rushes in to fill that low pressure zone. But here's the cool part. Because the Earth is spinning, that air doesn't just go straight in. It gets twisted, it spirals, and boom, just like that, you have rotation. The storm is born. All right, so we've got the spin, we have the beginning of a storm, but how does that little swirl evolve into a full-blown monster? Let's walk through its life cycle stage by stage. It all starts here, in stage 1, as a tropical disturbance. Honestly, it doesn't look like much. It's really just a messy, disorganized bunch of thunderstorms hanging out over warm ocean water. But don't let its looks fool you. It's busy soaking up all that energy from the ocean, basically getting ready for what comes next. Then we hit stage 2, the low pressure area. And this is where things start to get organized. Remember that heat engine we talked about? Well, it just kicked into a higher gear. The pressure right in the center starts to drop, and it acts like a vacuum, pulling in more and more of that warm, moist air from all around. You can almost see it happening. Everything is starting to get pulled towards one central point. And now, stage 3. This is the big transformation. Organized circulation. That inward rush of air finally creates this clear, powerful spin. You can see the storm really taking shape now. It's got a structure, it's got a developing center. This isn't just a random bunch of clouds anymore. No way. This is a living, breathing, rotating system. And finally, we arrive at stage 4, intensification. As long as this storm has warm ocean water to feed on, it just keeps getting stronger. It's like an unstoppable force. The winds get faster, the rotation gets tighter, and then you see it. That calm, clear eye forms right in the center. That is the signature of a fully mature, incredibly powerful typhoon. Okay, so we've watched it grow from a few clouds into a monster. But how do scientists actually measure this? How do they classify the power of these storms and put a number on all that destructive force? Well, it really all comes down to one thing: wind speed. And when you look at the numbers, the escalation is, frankly, terrifying. So a tropical depression has winds up to about 61 kilometers per hour. Then it becomes a tropical storm, and you're already up to 88. A severe tropical storm hits 117. Then you cross the threshold into a typhoon, with winds whipping at 185 kilometers per hour. But then there's that final massive leap to a super typhoon. We're talking sustained winds over 185 kilometers per hour.
That's not just a storm, that's a force of nature capable of wiping communities right off the map.
So, understanding the science is one thing, but surviving these storms? That's a whole different ballgame, especially if you live in a place like the Philippines, which is right in the heart of what they call Typhoon Alley. Facing this constant threat has really forced them to get creative, to completely revolutionize how they prepare for disasters.
And this quote right here really nails their new philosophy. The goal is to move from being reactive to being proactive. Think about it. The old way was to wait for the storm to hit and then rush in with aid and relief. The new way? Use amazing science and forecasting to get people out of harm's way before the storm even arrives. It's a huge shift from cleaning up the mess to preventing the tragedy in the first place.
So, what's the engine driving this whole proactive approach? It's something called Project NOAA. It was launched back in 2012, and its full name is a bit of a mouthful, the Nationwide Operational Assessment of Hazards. But what it really is this super sophisticated program that uses science and tech to give communities the exact information they need to get ready and, if necessary, to get out. But look, having all this high-tech forecasting is great, but it's totally useless if the information doesn't reach the people who actually need it, right? And that's the real genius of Project NOAA. It takes all this complex scientific data and translates it into simple, actionable warnings that people can use at the local, even village level. So how does it work? Well, Project NOAA really boils down to 4 key things. First, it creates these super detailed hazard maps, so you know exactly which areas are most at risk, like floodplains. Second, it runs all these different scenarios to predict just how bad a storm's impact could be. Third, it builds early warning systems to get the word out fast. And finally, it even puts the power right in your pocket with mobile apps that give you location-specific warnings. And this isn't just theory. You can see it working in the real world. For example, in southern Leyte, they've got localized sensors and sirens that give people immediate alerts right down to the neighborhood level. Or look at Davao, where they've put sensors in the river basins. These sensors can predict a flood and give communities downstream those crucial life-saving hours to get to higher ground. You see, this is so much more than just cool tech. It's about giving people the tools and, most importantly, the time to save their own lives. So what's next? Look, we're never going to be able to stop these massive storms from forming. That's just nature. But what we can do is fundamentally change their impact. And the way to do that is by merging this incredible high-tech forecasting with real, on-the-ground community action. The future of disaster preparedness, it isn't about trying to fight the weather. It's about building smarter, more resilient communities that can handle whatever nature throws at them. And that leaves us with a really big question. How can we take these amazing, life-saving ideas and adapt them for other vulnerable places all around the globe?